Hi, I am Said Abulfaz, and in this video I want to speak about the differences between gradient descent or batch gradient descent here and mini batch gradient descent and stochastic gradient descent. I want to speak about the differences between these three here. And as you can see here, as you can see here, in when we want to train a neural network to get the optimized result, we use a loss function, and our duty is to minimize the error, to minimize the loss function, and in that point that our loss function is minimum, we have the minimum of error and our neural network is optimized. As you can see here, suppose that this blue line is the loss function of a neural network, and our duty to train the neural network is that in each epoch we go from, for example, this place, we go in each step by step here to reach the here. Here is the global minimum loss. As you can see here is the place that we have the minimum loss function, means that we have minimum error here, and when we reach here, our neural network is optimized, and we can use that neural network in our real world concept. Okay, this is the main concept of concept in the neural network optimization. But as you can see here, we use gradient descent. We use gradient descent to reach the global minimum, and here is the global minimum of this loss function. Here is the loss function, this is loss function, and we should reach our global minimum here. For instance, in our first epoch, we start from here in the loss function, and in each step we should be closer to the global minimum. We use a gradient descent here, this method, as you can see, to go from this place, to go from, use another color, to go from this place in step by step closer to the global minimum. And here, what is this? This is our loss function, the gradient of our loss function according to this weight of our neural network. And as you see in here, or here the gradient of our, here is the gradient, you can see here with this line, with this dotted line, dash line, the gradient of our loss function here is this, and the gradient is in this direction. We should go to the opposite of this gradient, means that we use an opposite of this gradient. This is the gradient according to, or here the weight, and we should go reverse backward in the gradient direction to reach here. And this is our formula. Or new weight, for instance, or new weight is our old weight here, and subtract and using this subtract from the gradient of the loss function according to the weight. And we use here alpha as a random rate to control the step, how much we want to reach, how much speed we want to get here the global minimum. For example, if we have this learning rate is very much, we can go faster. We can go faster here, and if this is very low, we will get the global minima well slower. For example, here means slower, very low learning rate, and a suitable learning rate is good. For instance, here if the learning rate is very slow, for a small learning rate, a small learning means a slow convergence to the global minima. A slow learning rate means a small learning rate means a slow convergence. And if we use larger learning rate, for example, here if we use a larger learning rate, we go here, and after that we go here, and or we go here, or sometimes as in the larger learning rate, it can have, for example, some noise and get the global minimum here, or sometimes something worse. As you can see here, for the larger learning rate, for example, we go here, and with a larger learning rate we go here, and after that we go here, and we go here, and as you can see here, never we get the global minimum. Means divergence. Okay, we should, as you know, having a good learning rate is important for us, and this is our main function. But what is the difference between these three concepts? As you can see here, sometimes we use the word batch gradient descent or gradient descent. It means that we'll get all the data set and put all of our data in the neural network, all of our data in the data set, to go step by step here to reach the global minimum. This means batch gradient descent. That is here. As you can see here, this is a contour of our error function in this circle. This red circle is a global minimum, and here we have, for example, error A, and here we have more error. It shows that circle of some radius, that in each circle we have the error. For example, error here is B, error here is B, error here is B, shows that all the places in the contour that have the same error in each circle. Okay, I should write it cleaner, use another color. Okay, for example, here in this circle error is A, for this circle error is B and C, and you can see in this circle the radius is D, error is D. And if we use batch gradient descent or gradient descent, it means that we use all of our data in a data set to reach the global minimum, to reach what is here, global minimum. As you can see here, for 2 days minimum, for 2 days data, that we have a lot of data and we want a lot of data to be trained on the neural network. It's very use very much much amount of RAM or system, and you use many calculations. It's very time consuming, and this is not suitable for 2 days. And because that we have, that we have many data, and all neural networks are very big here, very large here, and there are many parameters in it that must be trained. Okay, this is very good you can see here, it's go here very fast, but it is not suitable for our real scenarios today. Another cases is that using mini batch gradient descent and stochastic batch gradient descent. Stochastic batch gradient descent means that in our data here, all get one by one every data in our data set. For example, I have a data set of 1 million records. For example, here imagine it 1,020,280,000 records. I get first data and train the neural network, and after that optimize our weight, and the second data I get and train the network. Third data, as you can see here, I get the one by one and any data in the data set to train the neural network, and it will reach the global minimum. But it is very noisy, as you can see here. It is very noisy, but it can reach the global minimum. And if we have a good network and we have a good optimization method. But as you can see here, this is very noisy, means that it is slow. For example, it should start from here, go here, go here, start from here, go here, and you can see here very much distance should be covered to get the global minimum. It's not suitable for today's problems now. Okay, another thing that we use today in a real world scenario is this mini batch gradient descent. That as we call that, for example, batch gradient descent, but it's in the this is the mini batch gradient descent in the real concept. It says that you get our data in some batches. For example, you have 1,000 data in your data set, and you get you divide this data into some batches of, for example, 64 data. For example, one batch has 64 data, another batch has another 64 data, another batch, and until the end, until that we can all the data, all 1,000 data in our data set is in one of our batches, and then we train our neural network with one batch. For example, first we train the neural network with this batch, and after that we change the network, the weights, and train with another batch, and train with another batch, and until the end. And after all of the batch is trained in our neural network is trained in with all of the batches, and epoch is finished, and we go to the next epoch. Okay, and this in real world scenarios, this is as you can see here, I choose a good color. This is or here. This shows that how we can reach global minimum. Here it is, as you can see here, it's a little slower from gradient descent, standard gradient descent, but faster than stochastic gradient descent. And this is something that we use for today's needs. This is for today's is used today, and we use that in our real scenario. But training neural network is not, as you can see here. In the next video, I want to speak about a little bit about how I can optimize a neural network. For example, here this is a real loss function of a real neural network, ResNet 56. This is weight of the skip connection. This is the real loss function of our ResNet neural network. A very ResNet is a very good neural network for classification, for image classification. As you can see here, there are many local minima here, and many local minima, but we want to reach here global minima. And reaching the global minima in real world in real scenarios of neural networks has some concepts. This is something that we want to cover in our next video. Have a nice time. If you are not if you want these videos, please subscribe to my channel. Sometimes I record videos about concepts of machine learning and deep learning and programming, and sometimes I do some real world projects in this video. Have a nice time. Don't forget to subscribe. Bye bye.